understand what is wave scatter diagram. Good morning, everyone. Today we are diving into a powerful tool used in motion engineering. That's also structural design. That's nothing but wave scatter diagram. It may look like a grid of colored box, but what it represents is the heartbeat of the ocean at a specific location, translating thousands of waves of observation into meaningful pattern. Now, what does it mean? Like if you see this is the wave scatter diagram. Here you see how many number of occurrences are happening. It's like millions of cycles are happening, and we will be having this wave period and wave height. This is significant wave height and major crossing wave period or peak wave period. So from here, what we will observe that most of the occurrences happens with 1 to 3 meter, I can say, and with the periods 2 to 3 seconds, it's a high frequency is happening, right? Too much happening for this frequency only with the less waves. So this is a tool to understand how the wave in the ocean is coming, like the meaningful patterns we can understand from this wave scatter diagram. So what exactly is the wave scatter diagram? It is a statistical representation of wave conditions over time, typically a year, showing how often a different combinations of wave height and wave period occur. You see here the combination of wave height. This is the wave height and this is the wave period. This particular combination 0 to 1 meter and 2 to 3 seconds, it's happening more often. That's why the number of occurrences is more. Here you can see this kind of visualization we can get, and this gives a more meaningful observation also. Otherwise we cannot get any observation from meaningful observation from the random scene. So this is the reason we are using wave scatter diagram in also structural design and ocean engineering, showing that shows how often different combinations of wave height and wave period occur. Each cell in diagram represents a unique pairing of height and period. The number in that cell or its color shows how frequently that sea state was observed. Here you can see this sea state was very frequently observed. And then reading the diagram, on the x-axis wave period is there. You see here wave period, and the other direction we have the wave height. That wave period is only the time between the wave crest, ranging from short choppy waves to long motion waves. On y-axis, here in y-axis we have the number of occurrences we have in the. We can see this y-axis. In y-axis we have this y-axis, and this is x-axis. X-axis wave period and y-axis wave height, and z-axis we have the number of occurrences. And where these two intersect, we get the frequency. How many times that condition happened during that year? See this condition, particular condition, 0 to 1 meter wave height, 2 to 3 seconds. How many times it's happening? It's a lot of time it's happening. It's like 500,000 or 500 or 5 million, something like that is happening. And you see this is wave scatter from 30 degree, like that for each degree interval also we can see. This is the overall for all directions, sum of all directions. This is the particular direction. This direction 0 to 1 meter, it's happening a lot, and with 2 to 8 seconds also it's happening a lot. This you can see this pattern. This is usually the Rayleigh distribution. So this is how we will come to know the Rayleigh distributions. It's happening like a more number of small waves is happening at high occurrences, and the high wave height and high periods, it's not happening that much, it's happening very low. Where does the data come from? Well, wave scatter data are built from real ocean measurements. So basically it comes from ocean measurements, most commonly from the wave rider buoys, which float on the surface and record continuous wave data. So you can understand like how do we get the wave data, this kind of scatter data means where does it come from? Where does the data come from? The wave scatterers are built from the real ocean measurements. They are measuring it. How do they measure it? They are using the wave riders to measure it. That wave riders means what? Those are the buoys that float on the surface and record continuous wave data. These buoys give us the raw time series, which we then process into histograms or matrices. For a full year of observation, we can capture hundreds of thousands of wave events, binned into categories of height and period. So we can have in a year, full year, we can have hundreds and thousands of wave events, right? So millions of cycles it can happen, million times it's going to happen, that particular combination. But waves don't just vary in height and period, they also come from different directions. So we break the data into directional sectors, typically 12 at every 30 degree increments, 0 to 30 degrees. 30 degrees. For each sector, we create a separate scatter diagram. or sum them all together to get a overall. The dominant directions is nothing but those with highest wave energy are critical for aligning and designing the offshore structures. So from the scalar data also we will come to know the waves with highest wave energy. So we will align the structure. So they will ask the orientation of the platform. Orientation of the platform depends on this particular highest wave energy also. We should not put the structure obstructing this number of wave occurrences. We should be aligned with that. We can orient the platform like that.